And to finish off for part 3, we will take an equation we've already worked with. We will sketch the graph of that equation a way that we've already learned. And then we will take the same equation again and show how the formula we just created gives us the x-intercepts. So let's see. The way that we learned before is to subtract 15. We will take this information right here, x squared minus 8x, and we will make a perfect square out of it. We know that minus 8x gets separated into minus 4x, minus 4x. Now I fill in the outside of my square, x minus 4, and of course, negative 4 times negative 4 equals positive 16. This square right here is exactly the same as this square right here, which means that inside of this square is 16, which got added to the equation, which means I need to add it right here. And that gives me y plus 1 equals x minus 4 squared. Subtract that 1 from both sides. What do I got? Y equals parentheses x minus 4 squared minus 1. And we know that I can take my vertex out of this. My vertex is simply the opposite of this, positive 4, and I keep this, negative 1. Positive 4 and negative 1. That's my vertex. And if I want to sketch the graph, I need to find the intercepts. And the way that I find the intercepts is by putting in 0 for y. And then, of course, solving for x. Add 1, add 1. I've got a square on the right side. I have a perfect square. So I take the square root, and I get plus or minus 1 equals x minus 4. Got to continue solving. So I got x minus 4 equals positive 1, x minus 4 equals negative 1. X equals 5. X equals 3. And I can sketch the graph because I now have my vertex. My vertex is 1, 2, 3, 4, negative 1. And then my intercepts were at 3 and 5. So there's a little sketch of my graph, the way that we've already learned. But I'd like to do it differently. I would like to find the vertex the first way I learned it, x equals negative b over 2a, which is negative 8, over 2a, which is 2 times 1, which is a negative times a negative is a positive 8 over 2, which is 4. And then I'll plug that into my equation. Uh, 4 squared is 16 minus 32 plus 15. 16 minus 32, negative 16 plus 15. Negative 16 plus 15 is negative 1. All right, looking good because I know I've got the same, I have the same vertex as what I got last time. But now I need to use this new crazy formula that we created to get the x-intercepts. Here's this crazy formula we created. And this says I can get the x values. I've got a b, an a, and a c, so let's see. Y equals x squared minus 8x plus 15. A would be the number in front of the x. Since there's no number there, we could just put a 1. B is going to be that, negative 8. C is going to be that, 15. Negative b would be negative 8. Square root of b squared is negative 8 squared. Minus 4 times a is 1 times c is 15. All over, the whole thing over 2 times a, which is 2 times 1. Let's just do some simplifying. Negative times negative is positive 8, plus or minus. Negative 8 squared is 64. Minus 4 times 1 is 4. And then take that whole thing and times it by 15. 4 times 15 is 60. All over 2 times 1, which is 2. Let's see, 64 minus 60 is 4. The square root of 4 is 2. And now I've got 8 plus or minus 2 over 2. 8 plus 2 over 2. 8 minus 2 over 2. That's plus or minus. That's plus right here or minus right here because I have both of them. Plus 2 is 10 over 2. 8 minus 2 is 6 over 2. 10 over 2 is 5. 6 over 2 is 3. 5 and 3, remember this was all x equals, so x equals 5 and 3. X equals 5 and 3. And let's take a look at what we've already graphed. We graphed at 5 and 3, which is precisely what we just came up with, 5 and 3. So when I sketch this graph again, I am getting the exact same values. It's the same equation, I've just solved it differently. Vertex still at 4, negative 1. My intercepts at 5 and 3. And there's my graph. Same exact graph. And just for fun, let's pull up our graphing calculator. Let's see if we can get this whole calculator fitting in the window. That's pretty close. Let's clear that stuff. And let's go ahead and put in x squared minus 8x plus 15 and hit graph. And there it is. There's our graph. It's looking good. It is looking good. I'll copy that onto our program. So bear with me for a moment. let's just drag it onto the page. And while it's probably a little bit neater than both of the ones I did, we can see that it's the same graph. So we have created a formula that will allow us to solve for the x-intercepts. This formula works for every quadratic equation. Because it works for every quadratic equation, we call it the quadratic formula. And we can solve for the x-intercepts by doing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thanks for watching.